All right, wave speed, frequency, and calculations. That is our assignment today. So we have our triangle here. Speed or velocity is equal to frequency times wavelength, right? So wave speed is equal to frequency times wavelength. So wave speed or velocity, V, is equal to the wavelength, which is this symbol here, lambda, times frequency. Guys, if you wanted to calculate frequency and you had speed and wavelength, what do you do?
Wavelength. No, speed divided by wavelength.
Good. Speed divided by wavelength. Okay. Now, period and frequency, they're inverses of one another. So if you are given frequency, if you're given F, you can solve for period, capital T. If you're given the period, you can solve for F by doing 1 divided by the other guy. The unit for wavelength needs to be the meter. Unit for hertz, or unit for frequency is going to be the hertz, and the unit for the period is going to be seconds. So here we are showing all our work. So we got a fisherman. He noticed that a float makes 30 oscillations in 15 seconds. The distance between 2 consecutive crests is 2 meters. What is the period and frequency of the wave, and what is the wave speed? Okay, so period, capital T. The time it takes to complete one cycle, or the total time divided by the total cycles. Well, what was our total time? 15. And what was our number of cycles that we made? 30. So 15 divided by 30, guys, is going to give us 0.5 seconds. And this is what we would type in right now. Okay. Now frequency. I can find frequency one of two ways here. I could do frequency is equal to 1 divided by the period, or the total number of cycles per time, in which case that would be 30 over 15. So we have 2 hertz. 2 hertz as our frequency. Okay, now they said that the distance between 2 consecutive crests is 2 meters. That, guys, is wavelength. So wavelength can be the distance between 2 consecutive crests. So I have lambda. We just solved for frequency. Well, now we can solve for velocity. So I just copy this equation up top. I copy this equation. I pasted it down here. And so I'm going to have 2 meters as my wavelength times 2 hertz, because that is my frequency. And that is going to give me 4. And what is the unit for our speed? Meters per second. Okay, so the next one asks, what is the wave speed if the period is 4 seconds and the wavelength is 1.8 meters? Well, our equation for speed is frequency times wavelength. We don't have frequency right now, but we do have period. So I can solve for frequency by doing 1 divided by the period. So you need to do that first. We need to do that first. So T is 4 seconds, right? So frequency will be 1 over that. 1 divided by T, which is 1 over 4. And that comes out to be 0.025. And what would that be? What is the unit for frequency? Hertz. Okay, now what they want is the wave speed. So I have my velocity equation up here, wave speed or velocity, same thing, is going to equal wavelength times frequency. I have frequency. Do I have wavelength? I do. It's given to me in the problem as 1.8. So I'm going to just type in my values now. 1.8 meters times 0.25 hertz. And that comes out to be 0.45. And the unit for speed again? Meters per second. Number 3, guys, I'm going to skip over them. You guys will have to do that one on your own, but, okay, what do they want? Frequency. They give you speed and wavelength. So you're doing speed divided by wavelength to find frequency. That's it. That's all you have to do for 3, but you'll have a chance to go back to that. For number 4, they want to know what the wavelength is of a wave traveling with a speed of 3 meters per second and a period of 6 seconds. Okay, well, first we got to do is we know that the period is 6 seconds. In order to use this triangle, we need frequency, wavelength, speed. We need 2 of those 3. Right now they give us speed, so we only have 1 of those 3. But with period, we can find the frequency. How can I find frequency with period? Frequency equals 1 divided by the period. So what am I going to do to find frequency? 1 over t, which I'm going to do 1 over 6. And that comes out to be approximately here 1.6, repeating, I'm just going to call it 0.16 for now. Call it 0.16 hertz. Now that you have frequency, you have speed, to find wavelength, if I were to cover that up, right, in our triangle, it would be speed divided by frequency. So I have, right, 3 over this 0.16 guy here. So let's type this in. And get 18.75 meters as my wavelength. I just pasted this equation from up top, guys. So you want to like copy this equation, Control C, that way you can just paste it. And then in order to solve for wavelength, I just hit equals V divided by F. That's what that guy would come out to be. Now, number 5. Number 5 says, a fisherman noticed that a wave strikes the boat every 5 seconds. The distance between 2 consecutive crests is 1.5 meters. What is the period and frequency of the wave? And then what is the wave speed? Okay, so when they're saying it, one thing strikes it every certain period of time, the time it takes to complete one cycle. So they're saying, hey, the period is 5 seconds, right? How long is it going to take for the next wave to hit? 5 seconds. Okay, well, what about frequency? Well, frequency, guys, is 1 over the period. So I'm going to do 1 over t. 1 over 5 is 0.2. Now, once you have period here and frequency, they want to know what the wave speed is. This is our equation. We have frequency as 0.2, but wait a minute, do we have the wavelength? What is it? Good, 1.5, because from our definitions, wavelength, all right, can be equal to the distance between two consecutive crests. So we have 1.5 meters times by the frequency of 0.2 hertz, and we're going to crank out 0.3 meters per second. So then getting to number 6, what is the wave speed if the period is 7 seconds and the wavelength is 2.1 meters? Well, what is our equation for speed? Wavelength times frequency. All right, bet. We have wavelength. We don't have frequency, so let's find frequency first. 1 over the period. So we're going to have 1 over 7, which we're just going to call 0.14 hertz. Now, once we have the frequency of 0.14 hertz, looking at the triangle, we have frequency, we have wavelength, calculate that, multiply those two together to get the speed. So, speed is wavelength times frequency. And we are going to do the wavelength of 2.1 meters times 0.14 hertz. And this cranks out a nice number of 0.294 meters per second. So we had our period, 1 over the period gives us frequency. Then we already had wavelength, so then it's frequency times wavelength. That's all right. So it was a 2-step. This one, they want to know what the period is of this wave that has a speed of 20 meters per second and a wavelength of 4 meters. Okay, again, period would be the time it takes to complete one cycle or the total time over the total cycles. Well, we don't have that kind of information here. So the only other way we can get that is if we know what the frequency is and do 1 divided by the frequency. Okay. Well, we have speed and wavelength. We don't have frequency, so dang. This is now becoming a very pain in my ass. Well, you have speed and wavelength, so you can find frequency. So we're going to divide speed divided by wavelength to get frequency, and then to get period, we do 1 over that number. So here we go. Here is our spot, but we are looking to rearrange this guy for frequency. So I pasted the equation and I rearranged it. So F equals V divided by wavelength, V over lambda. So I pasted that original equation and just you have to edit it around real quick to get what we need here. So we're going to do 20 divided by 4, which equals 5 meters. 5 hertz. There we go. Because that is the unit for frequency. I don't know why I put meters. All right. Next. I hate when that happens. To find period, we do 1 over the frequency. What's 1 over 5? Yep, sorry, 0.2. 0.2, not 0.25, it's 0.2. That's it for number 7. Right? Because they wanted period, but we need frequency first. So you had these 2 pieces of information to get frequency, and then T is 1 over F. Okay, guys, number 8, you guys are going to do on your own. Number 8, you'll do on your own. They want wavelength, but they give you speed and frequency. So triangle. They want wavelength, but they give you speed and frequency, right? So speed over frequency gives you wavelength. So you're going to have to do number 3 and 8 on your own. But so let's scoot down to the graphs. 7. Final answer was 0.2 seconds. So now let's scoot down to our graphs here. It said we have a snapshot of this wave given to the right. It has a frequency of 240 hertz. So keep that in mind. That will come into play. What is the frequency of this wave? 240 hertz. Okay, well, what is the amplitude? So, guys, to find amplitude, all right, from our definitions, that is from the resting position. Let's say the resting position is the blue line. So from the blue line to the top of a crest, or from that blue line to the bottom of a trough. So how high is the amplitude? So if I go from the blue line to here, what do we got? 10 centimeters. So I'm going to type in, right, 10 centimeters. What would that equal in meters? Slide the decimal to the left twice. 0.1 meters. It's the reason we need to do that is because wavelength, the next one has to be in meters. So the wavelength one is a little bit more of a pain, but let's just kind of show it. Okay, so if I said, if we start right here at this blue dash, this blue mark, one wavelength will be once this thing makes it one complete cycle. Right, so like basically, when would this thing start to repeat? So right here, right, it starts at 0, starts at that middle line, it goes up, above it, goes down, below it, comes back, and then right about there, it would start over again, starting going up and going down. So from here to here is from this spot to this spot is going to be our distance. This is going to be our wavelength. So we're going to call it, this would be 60, that's it. So this is 65. Call it 62 and a half. Let's call it 62 and a half. So it's 62.5 centimeters. What would that be in meters? Good, 0.625 meters. Excellent. Oh snap. Oh snap.
Oh, no.
Hey, everybody love everybody. ELE. ELE. Let's knock it off.
I'm scared.
Awful. Now, number C. Yes, I said number C. I meant letter C. Really? Really
What
that?
happens when
Okay.
you want to make fun of her too?
Letter C, lumber C, letter C. Wave speed, equation, ba-boom. We just kind of measured what the wavelength was, is 0.625 meters. But crap, what is the frequency? I forgot.
240.
Good, it says it up in the beginning. So 240 hertz. Multiply them Johns out, and you're going to get 150 meters per second. Ba-boom. What? Why we lose? What we lost? How we get lost? It's okay. It's fine. What, the 240?
Oh no, I'm just like I'm lost. Like I'm a little behind. Like I'm typing it slow.
Oh, my fault. My fault. How do you find the period? What? No. So scoot all the way up back to the top.
How do you move the what period you said?
How do you find the period of this wave? So if I scoot all the way back up to the top, period, guys, is capital T. How do I find that?
Total time divided by total cycles.
Total time divided by total cycles, but we're not given a total time or a total cycle. So what do I have highlighted up here?
T
T.
equals 1.
Good. So to find period, if you have frequency, you just do 1 divided by frequency. Do we have the frequency? Yeah, it's 240. So what we're going to do is we're going to do 1 over F, or 1 divided by 240, which is going to come out to roughly 0.0042 seconds. So now we're going to move on to number 10. So what is, in number 10, what is the frequency, or a snapshot of the wave is given below. The frequency they're telling us is a 120 hertz. So keep that in mind. What is the amplitude of the wave? Okay, so that's from the red line to either a crest or from the red line to a trough.
Wait.
Okay.
Is it 4.0? No. Okay, never mind.
It's okay. Does anyone else want to take a shot?
Wait, what'd you say it was?
3. It's going to wind up being 3, right? So from this red center line, from there to the top of a crest is an amplitude. So from there to there, right? If that's the case, right? If this is 0, this is 2, that means the y-axis is going up by 1. So 1, 2, boom. We would be 3. So that's okay. So amplitude is up and down, but only from the middle point. Someone in my other class went and did this. They went, okay, from the bottom of a trough, right, to like the top of a crest. So they thought it was 6.
Yeah, that's what I was doing.
All right, but amplitude is just from the middle point to the end. All right, so from the middle point to either a crest or a middle point to a trough, either one of those. So we're gonna write what? 3 meters. What is the wavelength of the wave?
0.03? Okay, never mind then.
It's okay. This is why we're working through it. So wavelength, guys, will be from any 2 consecutive, all right, points on the wave where it repeats itself. So if we start here at 0, we would go right to there, right? Because it starts here, goes up, down, back here, and then it would start the second wave where it goes up. So right there.
7.9 or 7.8.
Yeah. So if you notice, the x-axis is going up by how much? It's going up by 2. So this right here would be 2. This is 4. This is 6. And this is 8. And it's right in the middle of 6 and 8. So we would say 7 meters. Now that we have that, we have our wavelength. Excellent. We want to know what the speed of our wave is. So here is the equation. We have wavelength. What is the value? 7 meters. What is our frequency? Very good. 120 hertz. So multiplying those two things together, we are going to get 840 meters per second. And again, how do we find the period? If we know what the frequency is, how do you find period? Good. T equals 1 over F. And so what was our frequency? 120. So you're going to do 1 divided by 120, and we're going to get 0.0083 seconds. Remember, you guys have to complete number 3 and 8 on your own. But those ones I'm pretty sure you're just going to be dividing. Okay, you're looking and using the triangle up at the top. Okay, guys, so I posted the waves quiz for us here. I posted the waves quiz. So I'm going to do that. And then what I'm going to suggest to you guys is from last week, listen to this carefully. From last week, waves, notes, and concept builders. You want the wave notes up. I'm telling you right now, this will give you the answers to like 95% of them. I had someone drew it in my first period class. They were like, oh, I got a 56 on it. I was like, what? How? Did you not have the PowerPoint open? They said no. I was like, what?
So like, my question is, what kind of questions are these? Are they like problem questions or like just questions like, oh, like from notes that like you learn like simple like?
What type of wave is pictured, guys?
Transverse.
And if I wasn't sure?
Just look at the photos.
Transverse wave. Looks like this. Longitudinal wave. Looks like this. All right, you know what? I'm thinking it's longitudinal. So like, nope, it's transverse. That's what I meant to say. Why don't I say longitudinal? Okay, a material some waves travel through, such as a solid, liquid, or gas. I'm not sure, so let me go back. Mechanical waves, classified by how the medium vibrates. Again, I'm not 100% sure. Mechanical waves require a medium, material through which this is moving through, okay? And again, mechanical waves need to vibrate through a medium, water, solid, liquid, gas, those guys. So I'm going to say, I'm thinking it's medium. Yup. The length of a crest or trough measured from the middle line. From the middle line to the crest, what is that called? Amplitude. Okay, what are the high points on the transverse wave called? Crest. What about the low points? Trough. So you see how many of them are here, right? What is the distance between any two crests? Not 100% sure. Wavelength, distance between two crests. So I'm going to say wavelength. Cool.
Wait, one question though. So like, let's say if I read it, I'm not done with it, but I exit out.
It should save.
It would
Yeah.
renew? Okay.
The number of times a wavelength occurs in 1 second, measured in the unit called hertz. Yeah, frequency. Okay, all waves carry what? Not sure. Water, sound, light. Well, waves, what do? They carry energy from one place to another. And the source of all wave motion is a vibration. So, yeah, they all are going to carry energy. Sound travels what kind of wave? Transverse or longitudinal? Well, I'm not 100% sure, so let me go through. Example, sound waves. This is a longitudinal wave. Every single answer so far, guys, is somewhere in the notes. Which one of these guys here has the longest wavelength? Yeah, the one that has the most distance between its parts. Okay, well, which one has the highest frequency or the largest frequency? Yeah, the one where there's the most. C. C and G, what do they represent?
CG. Oh, the crest?
Crest, bang. What letter or letters
D.
represent trough? Just D. Which letters or letter represents the crests?
B and F.
B and F. What type of wave is this? Longitudinal. In longitudinal waves, the parts where the coils are spread apart, compression would be tight together, rarefaction.
That's so weird, so I was gonna guess that one too.
Coils close together, we just said it, compressions. What causes a wave?
Oh,
Got those good vibrations. Yep, that was awful. Yep.
when the frequency of a wave increases, what happens to the wavelength?
Decreases, they're inverse. So that's a good question, right? So like this one, guys, the equation is in your thing. Here about this one. When the frequency increases, what happens to the wavelength? So here's a picture that I'm going to show to you guys, right? They want to know what happens to the frequency, or if the frequency increases, what happens to the wavelength? So let me just go back a couple questions right for a hot second. Which one has the higher frequency? Which letter?
C.
But since it has the highest frequency, what do you notice about its wavelength? It's also smaller. So if I make it less frequent, like letter B, now what do you notice about the wavelength? It got bigger. So they're inverse of one another. As one goes up, the other's going to go down. Yep.
So this question, you know the photo that you showed us, there was, that I said I was seeing G at the crest? It says, same photo, I think, but the question is which vocabulary term is used to identify the distance between? Are they asking what it is, or what's? Like,
I can try the answers later.
Yeah, wavelength is the distance between two crests. So this thing is asking guys, hey, frequency is 5 hertz, speed is 25. Oh no, how do I find the wavelength? Well, go down to our speed equations here to find wavelength. Do the speed divided by frequency. Speed of 25 divided by frequency of 5. 25 divided by 5 is 5. Okay, it gives you a wavelength and speed. They want frequency. Again, if I want F, I need speed over wavelength. So what do? Speed divided by wavelength. Velocity, what is it? If wavelength is 0.5 and frequency is 150. So if that's the case, I'm looking for V. Frequency times wavelength. I'm doing 150 times 0.5. 75. Unit for frequency, we should know this. Here, what does letter A represent? What is letter A? Wavelength, because it's trying to go from green to green. B would just be the crest. It's representing it right at the top. C would be an amplitude. D would be our resting point, and E would be our trough. Which one has the longer wavelength? Obviously, letter D. Greater frequency, the one that's more of, letter B. And then you have a couple other things here, guys, and it has the equations for you. All right. If you're given frequency, period is 1 over the frequency. Sound travels faster in more dense mediums. So the more dense the medium, the faster it's going to travel. See you guys. All right.